Ooh, I forgot to add the webcam. Hello all guys. Today we're going to be streaming once again. Sorry if I haven't streamed in the last 1 or 2 weeks, but I was on holiday and now I'm back here and we're going to be talking about delegation and type aliases. Then next time we'll have functions, and the next time, functions including lambdas and inline functions, and then we'll have operator overloading and function builders. And then we'll look at the last concepts, which we already saw in some of our our courses, but like null safety, quality, this and so on. Probably we haven't seen async programming techniques and coroutines, as well as reflection, but we'll see how it goes and if we want to dive into that one. So the delegation pattern has proven to be a good alternative to implementation inheritance, and Kotlin supports it natively, requiring zero boilerplate. So since this description is not enough, I have generated one in ChatGPT, and it says that the delegation pattern is a design pattern which an object hands off or delegates some of its responsibility to another helper object. So it helps to promote code reuse and separation of concerns by allowing objects to delegate behavior to other objects rather than implementing everything themselves. So imagine a printer interface. You might have a class that delegates the actual printing logic to another class instead of implementing it directly. So we have a class that delegates printer implementation to console printer. So our class is I am delegating the implementation to console printer. So basically we have our interface, we have our print message, which is overriding the interface, and this delegate printer is actually implementing a printer as well, but it is saying delegate printer implementation to console printer. So in this example, delegate printer does not implement print message itself. So there's no implementation you can see in this class of the print message, but it delegates that behavior to console printer instance by with the use of by printer. So the use cases are composition over inheritance, and the reuse behavior from another class without extending it, linear code with separation of concerns. Kotlin also supports property delegation using by lazy, by delegates observable, or custom delegates. This differs computation until first access, so you will not be able to, it will not store directly Luca, and it will not print Luca until a name is actually called. Would you like a real world example? So let's see. logger by perform action. It doesn't have to implement the log itself because it implements logger by delegation. In step 4, to use it, we call logger, so we create a console logger, which is this one, and then we pass it to user service, and this will also implement logger by logger, so it delegates it using by logger, sorry. Okay, so let's see also the example that they have here. So you have an interface base with a function print, then you have a class base implementation in which we pass x, and that implements the interface. So we'll print, we'll just do some printing, and class derived. So in this case we say the by clause, the by clause in the supertype list for derived indicates that B will be stored internally in objects. So B will be stored internally in objects of derived, and the compiler will generate all the methods of base that forward to B. So the compiler will generate all methods of base that forward to B. Okay. Let's try and do this. An interface base with a method print, a class base implements base, a derived class derived that wants to behave like a base without writing its own print method. Okay, so this is similar to what was explained before. This is the key part. Derive says, I implement base, but instead of writing its own print, it says by B, which means please, Kotlin compiler, generate all the methods from base for me and forward their calls to the object B. So this is the key. In short, the derived will be exactly like the base instance you pass. No manual implementation is needed. Okay? So this is the key concept that we need to have. So let's see if fleet. Oh gosh. Okay, sorry, I have upgraded fleet. So now we should be good. Let's go here to our app. Sample app. Then we go over here, and we go next. So over here we say, let's create all of these. Delegation. Was this called base? Yeah, base or derived. doesn't matter. So the key concept here, delegation. Derived, so we create a base implementation, and then we say create derived by passing base, okay, and delegate the creation of the print method to base implementation, so to the B object. So I would copy what we had here as an explanation. So please tell Kotlin compiler to generate all methods from base for me and forward their calls to the object B. So that's what it does. Perfect. So that's the first advantage, and that's good to go. Overriding a member of an interface implemented by delegation. So override works as you expect. The compiler will use the override implementations instead of those in the delegate object. If you want to add override print message, the program would print ABC instead of 10 when print message is called. So you could also override one of those methods, but I think we can skip that. Note, however, that members overridden in this way do not get called from members of delegate object. So which can only access its own implementation of the interface members. So basically, if you have a message, they say, yeah, of course, this message will not be callable, let's say, from base implementation, because of course this message implement overriding is overridden by the derived class, and so B object will not be able to access that that method. So this is a little bit more interesting. Maybe let's also put print line so that we have all of we need. Let's do like this. So funny print line. All right. The reference text. Why unresolved X? I mean, it's there. Okay, I think I need to declare it. So like this, it should work. So, okay, I have declared saved X. Oh, maybe because we had to do something like this. Yeah. Okay. Yeah, and if you remove it, it's not gonna work. Now if we do derived dot print line, print message line. Okay, here they're overriding that one, and we will override print line message instead. And what we say here is written. Okay, let's run it. Oh, there's an issue here. Run. I'm not sure. Yeah, we need to import first. This will never work. Ba -ba -ba. Let's run it again. So we have an issue with X. Yeah, because X is private. So of course here we cannot use X. That's also another thing you need to know. All right. So we have X equal 10. Yeah, the first print should print the message 10. Where is 10? Print. Okay, yeah, so this message is our print, first print, and then we're print message line, we're doing this, and I don't see it in the console. Let me try and understand why. This is strange. I'm not really sure why I'm not seeing it. Print line, yeah. Oh God. Should should use this function. Don't know if it's something with the ID. I don't think so. Let's try and close it. There's some issues. A window. Yeah, still has issues. Yeah, I don't know if this is because of the ID. Let's try and open it. Android Studio. Sorry, we have this issue. Add configuration. We've never added some configuration here, so I think we need to do Kotlin. Let's try and see. Edit app.kt. What's going on here? So Gradle, maybe Gradle run. Let me check the command. We'll do it with Gradle. Gradle run. Let's try. Yeah. So yeah, but the issue doesn't look to be on the printing then. Oh wow. I'm so dumb. Because yeah. I was using this as main, but actually test phase. Come on. Test delegation should be this function right here. Now we run, yeah, from either ID. Import it, run. So we can run still here. Okay, so we are overriding print and message of derived. Message of derived. What was that? Yeah, it was just a way to show that you can access this message. Perfect. So sorry, it took a little bit long. Then let's see delegate properties. So with some common kinds of properties, even though you can implement them manually, every time you need them, it is more helpful to implement them once and add them to a library and reuse them later. For example, Lazy properties, the value is computed only on first access. Observable properties, listeners are notified about changes to this property. And observable Then we have storing properties in a map instead of a separate field for each property. To cover these cases, Kotlin supports delegated properties. So you can have a class with a variable p, which is a string and delegates the computation to the delegate object. Object, which is part of a class that we'll see here. The syntax is val or var, property name, type, and by expression. The expression offered by is a delegate because the get and set that correspond to the property will be delegated to its get value and set value methods. Property delegates don't have to implement an interface, but they have to provide a get value function and a set value for variables, of course. So for example, let's see, this get operator function get value. Here they're using Kotlin reflect. When you read from P, which delegates to an instance of delegate, the get value function from delegate is called. Its parameter is the object you can read, P, from, and the second parameter holds a description of P itself. So, for example, it can take its name. So let's say PoliMi example. So I'm creating a class, an instance of example here, and I'm printing the property P. In this case, it will print this, this the object. So this ref, and which is actually the value, the object of P that we're passing. So the string address, not the string address, sorry, the example address. Then we are seeing thank you for delegating and property.name, and here the property k property is passed. So I'm not sure what this k property is, but it's an object that contains certain name, and in this case, since we're passing p, so I believe what's happening is it is taking any k property and it's taking its name, and in this case, the name of p is p. Okay, so our property is actually p itself. Similarly, when you assign to p, the set value function is called, and the first two parameters are the same, and the third holds the value being assigned. So this will, when you do assign new, what it will do is it will print a value and say it has been assigned to property name in this ref, so in the object, in the object example. So this seems pretty clear. The get and set are basically delegated to this delegate class. Let's do create rename. So we have delegate, import, and then we create an example delegate, and here, yeah, pass this here. Then our next example is going to be delegate, sample delegate, import, so we have ed dot p, and then we have d dot p equals hello. Then we print again ed dot p. Run it. Oop. So yeah, we have example. Thank you for delegating p. Help has been assigned to p, and then thank you for delegating p again. Perfect. So that's pretty much it. So I have a question. Yeah, I want to do a test. Sorry. So this is my test. Um, yeah, let's see what happens. So even though I'm placing a string here, it is not using this method, but it keeps using the get value method from here. And if I remove it, yeah, it will complain. Must have with string. So it must be it must override this specific method signature. So this is why we also need Kotlin Reflect K property, because it's mandatory to do so. Okay, next, wow, we're still a long way to go. Next, let me see, standard delegates. The Kotlin standard library provides factory methods for several useful kind of delegates. Lazy property is a function that takes a lambda and returns an instance of lazy, which can serve as a delegate for implementing a lazy property. So this first call to get executes the lambda pass to lazy and remembers the result. So this is important. And subsequent call to it simply return the remembered result. So they will not do any computation. By default, the evaluation of lazy properties is synchronized, and the value is computed only in one thread, but all threads will see the same result if the synchronization of the initialization delegate is not required to allow multiple threads to execute it simultaneously. Pass this application as parameter to lazy. So let's see this in action. If you're sure that the initialization will always happen in the same thread as the one you use the property, you can use lazy thread. The lazy thread safety mode none. It doesn't incur any thread safe guarantees and related overhead. Okay, so let's try this, and I suspect that we will have printed only in the first line and not in the second one. App, test delegation. Let's delete this one, and let's run it. Yeah, that's what we did have. Let's go to observable properties. So delegates observable takes two arguments, the initial value and the handler for modifications. That's interesting. So the first one is the initial value, no name. Then you have delegate for modification, properties, old, new one. And property, what is prop? I don't know. So the handler is called every time you assign to the property. After the assignment has been performed, it has three parameters: the property being assigned to, the old value, and the value. Okay, so the prop is the value itself. So here we're creating a user, we're assigned, which has a name, string, which delegates the computation, let's say, of the set to this method, and it accepts an initial value, and it will allow when you assign to it, it will have three parameters: property, old, and new. If you want to intersect assignments and veto them, use vetable instead of observable. The handler passed to vetable will be called before the assignment of a new property value. So let's try this. User .kt import. Oh yeah, you see this is k property, this is old, and this is new. We might print also prop name. And let's go back to app, user delegate, and dot name. Yeah. User dot name equals to hello. So yeah, we can see initial value of property, which is old, is transformed into new, and hello is transformed into pizza. Yeah, so old and new values, and here we have the name of the property itself. Okay, you can do use Vitable. Let's see. Delegates dot Vitable none prop all new, and then we have PoliMi. This property so it has to return a boolean value. Let's do it quickly. Delegate so yeah, we're almost good. So yeah, with the age. So we give an initial value of 0, then we pass the property old new, and then we say this is a boolean. So new greater than or equal to 0 is only possible. So yeah, so this is useful because you will have user.age. If you assign 10, it's going to be okay. If you assign -1, it's not going to be okay. And if you assign 8, it's going to be okay. Let's try it. Yeah, I'm trying to change, but what if I print user.age? It should say 10, 10, 8, because this change is not allowed. It's there's a veto on it. This is nice, I would say. This is very useful, for example, if you need to do age validation. But don't want to restrict with a check. Next, let's see what we can do. Delegating to another property. Boop, boop, boop. A property can delegate its getter and setter to another property. Such delegation is available for both top-level and class properties, member and extension. The delegate property can have a top-level property, a member or an extension property of the same class, and a member of an extension property of another class. To delegate a property to another property, use two semicolon qualifier in the delegate name. For example, this delegate or my class delegate. So yeah, like let's see, top level, another class int. Then we have my class, which is member int, another class instance, which is a class with delegate instance. Then we have delegate to member by this member int. So this delegates to member int, and top level delegates to top level int, delegated to another class So this says it's useful when you want to rename a property in a backward compatible way. Introduce a new property, annotate the old one with the deprecated annotation, and delegate its implementation. So for example, I have new name, use new name instead, replace with new name. So delegate the implementation to new name. Then you have a function old name equal to 42 will use the new name instead. Let's see. Yeah, we could use new name instead of this. Old name is a string. Okay, let's run the same example with print line user dot old name. So old name will print pizza, but it will have a deprecation warning as well. All right, so yeah, here this is a little bit of a cumbersome example. Storing properties in a map. One common use case is storing the values of properties in a map. This comes up often in application for things like JSON parsing or performing other dynamic tasks. In this case, you can use the map instance itself as a delegate for a delegating property. So we have a string which delegates to map. In this example, the constructor takes a map. So when you create user, you must pass a map. And delegated properties take values from this map through string keys, which are associated with name of properties. Okay, this is interesting. This also works for variables properties if you use a mutable map instead of a read-only map. Yeah, of course, here they are defined as variables. This is nice. Let's do this. This had to be a string of any. Yeah, because we might use address, but not that, but address code. Address code is code. Yeah, maybe. So now when we create the user and delegate, we pass a map. When we say address is via of test and code address code is 22, and if we print line user.address and address code, we should have them both. Yeah. Of course, string cannot be cast to int. So if you mistype the type inside your address code, you will have issues because we're passing a string here. Now it's good. And the same will be for this. So you need a mutable map. If you want, for example, a property to change, like C string by map, and you can do that. And here we have what was this city to Rome, and here you can have row city, and then you can have Rome, Firenze. Let's run this. Yeah, so you can change Rome to something else, like Firenze, if you do user.city and assign the new value. And this will be allowed. By the way, map, I think will be, what is initial map? Let's see, string, yeah, not string, but I just want to see it printed. Initial map. Okay, so if you do this, it will say it's missing in the map. Yeah. Oh, okay. Instead, Firenze has changed. So initial map is not actually the initial map, but it will change. Immutable map. So it will take the reference map, and so if you change something inside, like city, it will change also the mutable map. Interesting. Then we have local delegated properties. You can declare a local variables as delegated properties. For example, you can make a local variable lazy. So our local variable lazy is memoized full, and if some condition happens, do something. So the memoized variable will be computed on first access only. Yeah, I think we said this already. If some condition fails, the variable won't be computed at all. Yeah, this doesn't make a lot of sense, this example. Oh, okay, so this is what I think I was searching this. So basically, since this is lazy, it's not computed until um, some condition is verified. So this is valid, is not computed until some condition is verified, which is very useful in many cases when you do some computations. So make an example with this code. Make a real world example with this code to show that is valid. Unless some condition is true. So let's see what it generates. So we have our user, we have our init, have our is valid, which checks if name is not blank, and if that this happens, then it does something. So let's copy it here. Then we have our function example. We may have it inside here as well. Right. And let's run example. So let's do this. Oh yeah, this has to be a companion object. Method. And it's called from here. Perfect. Yeah, here we need. See, let me check. Name is not blank. So we need to pass Nepal. Let's see if we don't. Okay, so we have case one, some condition is false, conditions are not met, or user is invalid, and this is because we're passing some condition equals to false. So some condition is false and the condition not met or user is invalid, and this is not even computed even though we have passed no name. Our initial value of name is no name. So this is not even computed is valid because you don't see the print line here. Instead, validating user is done when we call the function with some condition to true, set to true, and this will check if user is valid, and it will also print the memoized user and do something. So it will call this function here. And last one, which is not available here, in this case, some condition is true, but we have user.name equals to empty list, empty string. So let's do user delegate. Huh. Oh, so here I'm passing a function which returns user delegate. Why? Compute user. And is valid is a function of this class. I mean, why cannot it be like this? Okay, element get value method. Now the following function is suitable. So it must be a function. So what I mean here is we should have this and then not name. Oh yeah. Let's do user. Okay, so we're basically what I'm doing now is I'm returning you, but I'm assigning a name, an empty name, and then we're passing this lambda function to the example function, which is like a static function, and the sum condition. So we compute the user, so we create the new user only if some condition is met, and then when we have computed the user, we check with the returned user delegate if this user is valid. And let's run this again. We should see conditions not met or user invalid, because the user is invalid in this case. Great. Next, let's see what we have in our docs. Oh, that's a lot of things still. Property delegate requirements. For a read-only property, like a value, a delegate should provide an operator function getValue with the following parameters. So this ref must be the same type as or super type of the property owner. For extension properties, it should be the typing extended, and property must be of type K property or its supertype get value must return the same type as the property or its subtype. I think we already saw this. Yeah, but it should return a read-only property value. It should return a resource. Okay, but resource is a custom class. For mutables, what changes is that you can have a set method as well. And if value is of type research, then you can assign it. Read write property, read only and read write. Varchar value and get and set relational rules for delegated properties. So I think I'm out of energies for today. So I think I will just close it now because I don't want to go too fast. So we'll continue on from here next time. Maybe I will do a quick live stream tomorrow to finish this and type aliases. So thank you all for watching, and I hope to see you tomorrow. Thank you guys, but I'm sorry I cannot go on anymore. Sorry. See you tomorrow. Bye.